In this video, we're going to cover section 1.7, writing proofs. So, let's start. We have a theorem is a conjecture that is proven. So remember, we had our inductive reasoning looking at patterns to find a conjecture. And then if we prove that conjecture to be true, then it is a theorem. So a proof is a convincing argument that uses deductive reasoning. So after we've used our inductive reasoning to come up with a conjecture, then we need to use deductive reasoning to prove that conjecture is true, and then it becomes a theorem. Mostly in this class, we will deal with two column proofs, in which statements and reasons are aligned to organize and present a proof. Okay, so let's prove the vertical angles theorem. Okay, so the vertical angles theorem states that if we have vertical angles, then they are congruent. Okay, so vertical angles are congruent. So let's look at this. We're going to write our statements here, and then the reasons those statements are true over here. Okay, so I'm going to write angle 1 and angle 2 are vertical angles. This should be a 2 up there. And the reason that I know that that is correct is because it's given to us. Those are our conditions. So, number 2, our second statement, I'm going to say the measure of angle 1 plus the measure of angle 3 equals 180 degrees, and the measure of angle 2 plus the measure of angle 3 equals 180 degrees. These are two very similar statements, so I'm going to include them on the same line, and they have the same reason. How do we know those are true? They are supplementary angles. Now, since both of those sums of angles equal 180, what we can do is we can write them equal to each other. So the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. This is the transitive property of equality. I'll tell you a little bit more about that reason when we are finished. Now, what we're going to do is we are going to subtract the measure of angle 3 from both sides because it's the same value. That means the measure of angle 1 has to equal the measure of angle 2. And that's the subtraction property of equality. Now, if the two angles have the same measure, then they are congruent. This is the definition of congruent angles. Okay. Now, these properties of equality, this is our arithmetic properties. So things we did back in middle school, like a times b times c is the same as a times b times c. That's the commutative property of equality. So the transitive property says, well, if a equals b and b equals c, then a equals c. That's the transitive property. So we use two properties of equalities here. And this proves our theorem. And if we restate this in regular words, well, if 1 plus 3 is 180 and 2 plus 3 is 180, that means 1 and 2 have to be the same. And we showed all the steps to prove that conjecture that vertical angles are congruent into a theorem, and that's the vertical angles theorem. Okay, theorem 1-2, congruent supplements theorems. If two angles are supplementary to congruent angles, or to the same angle, then they are congruent. This is the symbol for congruent, without the little dot in front. So it's like an equal sign with the wavy line on top. So if two angles are supplementary to congruent angles, or to the same angle, then they are congruent. That's what we used in our previous theorem, saying 1 plus 2 is 180 and 2 plus 3 is 180, so 1 and 3 have to be congruent. That is where this congruent supplement theorem comes from. Now we have congruent complements theorems. Same thing, just instead of adding up to 180, they add up to 90 degrees. If two angles are congruent, complementary to congruent angles, or to the same angle, then they are congruent. All right, we have a few more theorems here. All right angles are congruent. That means if angle 1 is a right angle and angle 2 is a right angle, they are congruent to each other because they have the same measurement. Sometimes theorems are obvious and we're like, well, duh, that makes sense. Other times it takes a little bit to understand why they are correct. If two angles are congruent and supplementary, that means if I have two angles that add up to 180 and they're the same, that means they have to be right angles. In linear pairs theorem, the definition of a linear pair is two angles that form a straight line. So the sum of the measures of a linear pair is 180 degrees. So now let's do another two-column proof. So given that the measure of 1 equals the measure of angle 2, and the measure of angle 1 is 105 degrees, prove that the measure of angle 3 is 105 degrees. Okay, so measure of angle 1 equals measure of angle 2, that's given. And the measure of angle 1 equals 105, that's given. Now, if these two angles have the same measure, sorry, I misstated that, prove that angle 3 is 75 degrees. That makes more sense. Well, the measure of angle 2 has to be 105 also. This is the transitive property of equality. That's how I'm going to abbreviate property of equality. So because they equal each other, and this one's 105, angle 2 has to be 105 also. All right, line 4, angle 2 and angle 3 are a linear pair. Definition of linear pair. Now we need to state that because we're going to use that now and say the measure of angle 2 plus the measure of angle 3 equals 180. Because they're a linear pair, we can use the linear pairs theorem. Now that means 105 plus the measure of angle 3 equals 180. That's the substitution property of equality. That means measure of angle 3 equals 75. because we subtracted 105 from both sides, so that's the subtraction property of equality.